if you have this is going to apply to a lot of you, but if you have a site on VIPGo or WPCom VIP, can you raise your hand? How many folks who manage sites? Okay, lots of folks. That's great. And if you're on a team member at VIP, can you also raise your hand if that's you? Okay, cool. So there's a lot of my colleagues in the room as well, and a lot of folks who are managing sites. And I'm going to deputize my colleagues as I talk about this today. There are a lot of folks who deal with the same stuff I do who are in the room, so please add or subtract or correct as I go along. And if there are questions while I'm talking, please just stop me and interrupt, and that's fine too. So a little bit more about me. My role on VIP, I'm a developer on the team. I work on the support part of VIP on the enterprise squad, which means I get to work on your code a lot, those of you who are VIP clients, and and help you work through your problems related to performance and security and a lot of other stuff like architecture. I have been doing this now for something like 4 years. It's gone really fast. Like, it doesn't seem like 4 years, but that's how long it's been. And so I think the goal of this talk is just to roll some of that thinking and experience that I've maybe not had time to roll up into an actual presentation over these 4 years and relate it to you. And so it was really both kind of intimidating and gratifying to follow Rick, because like this talk is a little bit of a complement to what he was talking about, whereas he looked at stuff from a data point of view and a very wide perspective. I'm going to be very specific about WordPress. And whereas he spoke a lot about the front end and the page render, I'm going to be fairly specific about the back end. And where he had a lot of numbers, I'm going to have a lot of stuff like about techniques and ways to think about this problem. So hopefully it'll somehow, all of this will come together into a couple of takeaways that you guys can use. But so let's start. So I'm going to specifically talk about page generation. Mo, who was in here before, mentioned specifically that that's like a major both strength and concern that we have as a team here in VIP. We host your backends, so we're very concerned about how they behave and perform. So in this talk, I'm going to be focusing on page generation and backends, but I think maybe a lot of the ideas you can kind of, having what Rick talked about in your mind, you can apply them to other areas too. So to be specific, the page generation, there's a lot of sort of different definitions of what that is, but essentially it's like the time between when PHP starts executing and when it's done. And then if you want to include the part where the result of that page, generated page, is delivered to the browser, you can include that too. But it's all involving the server and involving usually that initial request that's going to start off all of the other requests that will eventually build your page. So this is actually the 20%. In Rick's like 80-20 split, I'm really talking about the 20% here. But it does have some particular value that's kind of specific to some areas maybe that Rick didn't talk about. So I'll go to that. And the way I'm going to organize this is I'm going to talk a little about the why you should care about page generation, like what the so what of it. It's a bit of an ephemeral kind of number at times, so I thought it important to talk about like why teams should really prioritize this kind of work, and then we'll spend some time doing a tour of how we work on page generation time and stuff like that. For those of you who this is your bread and butter and you do this all the time, a lot of this, some parts of this you will have heard before, but I try not to dwell on like the workings of tools that you probably know well, but I'll do an overview of those. But let's start with the whys. So, or this is sort of an overview of both the whys and hows. So the whys, which we'll start with here, page generation produces better user experiences and better app experiences. So it might not be the dominant factor in how a user experiences the loading of a page, but it has some important effects there. And some of those are fairly binary, like it can affect whether your page works at all. It delivers value, particularly internal value to organizations that can isn't often talked about, so we'll talk a little bit about that. And it tends to produce better software in like kind of mysterious other ways that I'm going to talk about here in a second. So teams that focus on these things get a lot of benefits. We'll talk about those whys. Then we'll talk about a few myths associated with why teams end up not caring about this. And then later we'll go through the hows. So how to think about the problem in general, what specifically is challenging about thinking about page generation in terms of WordPress. And then we'll do a quick tour of some tools. And then I want to end by talking about teams and how our team can help you with this problem. OK. So faster page generation definitely leads to better overall performance. As we learned, it's not the dominant factor there, but it is a factor. The 20% number is the golden rule, is what you hear a lot, but it contributes probably, depending on how your site behaves, some percentage of the overall speed. The variations have therefore a significant impact. If you can make savings on your backend performance, it's going to impact your user experience, and particularly those early indications of response are affected by it. It's also important to all sorts of sites. As more and more sites rely on very quick responses from endpoints, it becomes important in a headless context too. So some numbers associated with site response that you often see. These were, I don't have a citation here, but these are numbers you often see associated with the sort of neuropsychology of how that initial response to a request feels. It's said that responses of about 100 milliseconds feel almost instantaneous. So if you can get whatever your first response to the browser is at under 100 milliseconds, it feels almost instant. We begin to feel sort of a perceptible delay that's identifiable as a delay at around 300 milliseconds. And then at about 1,000 milliseconds or a second, which again in Rick's total load numbers is still considered really fast, you begin to feel like you're waiting a little bit. So the kind of savings you can make can actually sometimes even shift a response into these psychological categories. So I just thought I'd put these numbers up to underline that these are the savings we're talking about have real-world effects, and they have effects on how people perceive your app. So what's the value of working on the backend performance of your code? There's basically a lot of value here. And as I indicated earlier, some of the value is not so much the qualitative experience of the app, but whether it survives certain events. So we've found over and over that performant code lowers the risk that the code will cause an outage, increases the stability of your site, makes your site more resilient to events. A lot of you operate media or news sites or sites that have very spiky traffic patterns. So tuning for performance allows you to survive more of those kind of events. Probably many of you or some of you have had the experience of an anticipated event coming up for one of your sites, in which we'll help you prepare for that event by tuning performance in anticipation of it. But not all events can be anticipated, right? A news event could happen at any time. And so you're in the business of needing to be available or to be ready for those unexpected events too. So event resilience and greater scalability is the value we're really thinking about here. If you have better built-in backend performance, you're going to need less other kinds of mitigation. So less caching, less thinking about proxies, less doing other stuff to make sure that your site stays up. So that's an immediate savings, if not necessarily in terms of dollars, although sometimes in terms of dollars. Reverse proxies, depending on which one you use, can be expensive. But it's just one thing less that you end up having to ever think about, too. We see a high correlation between performant code and simple code. So and I'll talk about that a little bit in a moment here. But well-tuned and well-calibrated backend code leads to less, we found leads to less technical debt. It's not a universal rule, but overall that's the trend that I've certainly noticed. And kind of as a corollary to that, clearer, more well-understood and simpler code leads to more portability and flexibility. So a lot of you, or some of you, might be in the process or contemplating a move between our two platforms. So taking your code, moving it off of WordPress.com, moving it on to Go. Generally, this works okay. It's all WordPress after all, but even that move is going to be aided by any kind of simplification. So, and then I sometimes think of, often we think of the value of performance in terms of just its value to human beings, which, of course, that's what we should worry about the most. But as anyone from Google can tell you, it's important what robots think about your site as well in lots of different ways, right? So while we might worry about the pieces of content that are getting a lot of traffic and how they perform, there's also a long tail of content, and it's important how that performs too. So you have your active content over here that is getting super hammered by traffic all the time, and then you have this super long archive. I found people don't always think about how their archive is rendering, and that can be an important factor for how robots perceive your archive. I mean, the long tail's more crawler dense, less humans looking at it, more robots looking at it all the time, and it's less cached overall, especially with the whole page caching strategies that we use, like particularly bad cache, but also varnish. So if you think of a piece of content that hasn't been visited in a while, it's less likely to be cached and more likely to be encountered by a robot than a human. So how do those pages perform compared to the recent content? So these are all ways in which thinking about performance gives you a lot of free value. And we'll dig into some of these here in a little bit. So as I hinted already, performance tuning and building performant backends leads to better code and better development teams. That's a correlation I've noticed. So and I think this all comes down to, particularly in WordPress, and we'll go into some details about this in a moment, it's actually not always easy to figure out why code is slow. Therefore, if you are a developer who actually is able to do that, it is a sign that you've figured out some of the fundamental workings of WordPress. So we find that performant code is written by really engaged developers, and that understanding performance problems is one of the best ways to learn about how WordPress actually works and what it's doing underneath the hood. It also, like on the sort of negative side, really engaging with page generation and improving it helps you avoid over-engineering and a bunch of unhelpful patterns. So I think I'm going to talk about the unhelpful patterns real quick, but then we'll go on back into the positive stuff. These are some of the development patterns that we've noticed very broad strokes here, tend to worsen backend performance. The first one is layers of code abstraction on top of the WordPress API. So every layer that you built on top of the simple functions, actions, and filters that WordPress provides is an opportunity to introduce other stuff that happens. It's not always bad. Sometimes it's actually done with the best of intentions. People will, for example, build abstractions on top of WordPress functions in order to cache them. We ourselves actually do that. But if it goes much beyond that, or too many layers beyond that, we've noticed it can sometimes mean that you lose control over all of the stuff that ends up happening in other contexts where those abstractions are invoked. Also, abstractions on top of native templating for WordPress tend to introduce the same kind of complications. So this would be like PHP templating engines, stuff like that. I've indicated a couple other ones. I think this one here is maybe a little bit harsh, but sometimes assembling queries, particularly components of WP query and stuff like that, in very complex ways that are difficult to keep track of. Highly conditional parts of queries that are inserted at different times or different places in the code. Plugins that affect queries in highly variable ways. Stuff like that tends to be associated with poor backend performance. And then very broad query filtering is another one. Filtering queries in contexts you didn't mean to filter them in. And then the other one that's worth mentioning that I've noticed over the years is allowing data changes. So this would be things like settings, editorial configurations, organization of parts of pages, widgets, menus, things like that. Allowing those things to lead to unchecked large changes in backend behavior. So lots more queries when you traffic a page in a certain way, or turn on a feature and all of a sudden lots of extra queries begin to happen. So those are some of the sort of unhelpful patterns we've noticed. And again, the point of all this is to help folks think about how can we organize ourselves to avoid those, but those are what I've noticed. But on the good side, you know, going back to this idea that developers, I've seen development teams and developers improve in all sorts of unexpected ways when they build with performance in mind. So building with performance in mind sort of forces you to think about the mechanics and minutia of how WordPress renders pages. So like, what are all the actions and filters that happen during the course of rendering a page? What are the interactions between your theme and plugin code and the actual queries that are produced in the end, right? That's actually a really hard one. Like, how do I trace the cause and effect between turning on a plugin or implementing a template in a certain way, and then the end result, which is like the database queries that are happening. It helps drive understanding of database concepts. How are WordPress tables actually organized, and how should they be queried? So and then a general sense of how to build for scale. Like if you're building a feature, imagining the feature running at a much higher concurrency than you might otherwise. So these are all the habits that we see develop on teams that really take this seriously. So I wanted, before going on to like the hows and the mechanics of how to organize ourselves around this and how to use tools and stuff, I wanted to just maybe briefly address myths that I sometimes have heard over the years about other strategies you could use to address backend performance. So a lot of people think you can just throw hardware at it, or you could, you know, build. If it doesn't work, if it's not quite fast enough, just increase the number of servers, spin up some more containers or something like that. And I think I even early in my career heard like somebody really seriously talk about code performance and hardware as sort of just a tandem, and either you have to do one or the other. And while this might be true in some contexts, it doesn't deliver all of the other benefits that I had mentioned earlier and sort of just delays the problem. So I guess these myths are more like Band-Aids that I'm describing that people sometimes recommend we use. There's a persistent problem with thinking that back-end page generation issues can just be dealt with later. They're not very interesting or like kind of compelling or obviously performance or revenue impacting in the moment, although I think we're learning today that that's not true. But so they tend to fall down folks' prioritization lists. They're not the latest feature that is needed for ad tech or editorial. So they struggle to get up that list. So this is another coping mechanism that we sometimes see on teams. They are aware of the problems. The choice is just to fix them later. Proxying or putting a shield up in front of your website is a pretty common strategy too for dealing with slow page generation. And it can work. I mean, the difficulty then is that you introduce an extra dependency for your entire site. And you sort of eliminate you box yourself in, like you can't often run your app from out behind the proxy, and this has a whole bunch of knock-on effects involving portability and other issues. So, and as you know, we also offer this great utility called Elasticsearch, which can really help you speed up many of your queries. However, it's I won't go into all the details here, but it's not a panacea or a solution or a total solution for slow performance either. How many of you folks out there use ESWP query or something like in our platform? So lots of you, yeah. And I think the idea here is that we provide it because we know WordPress has particularly challenging areas that need to be addressed. It generates queries that are bound to be slow, and for those queries, we want to offer you a way to speed up those queries. But it's not meant as a blanket replacement for using the database, I guess is what I'm meaning to say here. So in other words, there's no magic pill for solving these problems. The real way that I've found that successful teams get through this stuff is by diving in, accepting responsibility for it, and understanding it. So I want to spend kind of the rest of the time here talking a little more about the mechanics of how, if you have a team, you might decide to begin working on this stuff. And then at the end, we'll have a time where I'd love it if you guys could share with me and with everybody how you think about backend performance and how it works on your teams. So we'll go through some stuff here on just general concepts, some brief tour of tools, and then I want to talk about a little bit about team organization, and then we'll throw it open to you guys. So page generation happens on the PHP level. It's actually composed of a couple, on the server anyway, it's composed of a couple components. There's PHP execution itself, and then there's a wait time, which is associated with all the other stuff that happens sort of outside PHP, but also on the server. So these are things like database queries, issuing the query and waiting for MySQL to respond to the query. Issuing a remote request and waiting for the response to that remote request. All of these taken together are page generation. It's, of course, these guys over here, the wait time that turns out to be the real problem. PHP execution is rarely the issue, as most of you probably know. It's possible to write really, really bad PHP and make it like run for a long time, or write some regular expressions that take forever to resolve, but it's kind of difficult. It's very, very easy to write stuff that will produce terrible database queries. So I've begun to think of all of this as in all the stuff inside of page generation as a series of kind of units of work. And the only way to really dig into trying to solve these kinds of problems is to break down page generation into smaller bits and understand each of the bits. So you can think of the total time it takes to generate a page as a bunch of units. These can be function calls, database queries. In WordPress, it's often useful to signpost all the filters and actions, all the hooks that fire during a page generation. And then taken together, these comprise the page generation itself. So the time it takes to generate a page is actually the time that it takes to complete all of these kind of units of work. So sometimes just in my mind, and this is completely abstracted here, it's useful to just break down any sequence of page generation into a sequence of these series. And here's just sort of an example I threw up that's entirely simplified. But if you think of a page that has sort of a series of these events, functions, queries, hooks, each is going to be associated with both a time and also a frequency. So like, how long does each of these units take to perform whatever it does? And then how often do each of these units of work have to happen in order for the page to be rendered? These two things, the time and then the frequency, are really kind of all that you need to know in order to solve this problem. And all the tools we have, all of the techniques we use are dedicated to either to understanding one or both of these two things, and then improving one of the two things. So high frequency is one of the ways in which page generation can go sideways. So that means you might have an event happening in your page far too often. This applies to things like, especially actions and filters. Perhaps you've added a callback to one of them that happens very frequently, more frequently than you intended. It can also be due to artifacts that appear on the page, like those changes in data I mentioned earlier. Perhaps there was a configuration of your page that caused an event to start happening very, very frequently on it. And then there are also just programming structures like the loop. It's possible to write loops unintentionally that do very expensive things every time they run, or run very, very many times. And then there's high cost or high time to execute. And these are things like, so this would be the amount of time it takes each of the events to happen. So we're talking here about queries that don't scale very well. That's really sort of the main culprit. And under bad queries, we have things like queries that look at the entire table in order to do their work. So stuff that performs full table scans. That's usually a result of not using an index or looking at a very large table. The other kind of thing that would fall into this category is uncached or frequent remote requests. So anyway, that's just going back to these two things. Like, got stuff that takes a long time or stuff that happens very frequently. And this is sort of just an illustration that either can be a problem, right? You can have a sort of relatively expensive item here, but it only happens once. Or you can have a relatively cheap event, and it happens 200 times. So you get to decide, as someone who's tackling this problem, which of those problems it's appropriate to solve and how. So I'll quickly go through, because I think there are many, and in the notes I'll send out, I'm going to include a lot of links to some existing presentations that really go into the mechanics of like how to deal with some of these issues here. But I'm going to mention the techniques that we have for reducing the frequency of some of these events and reducing their weight or cost. So as WordPress renders, we have access to lots of tools to reduce how often expensive stuff has to happen. So this is stuff like both non-persistent and persistent caching. Non-persistent being just saving something that you have to calculate in a page load that's used 100 times during the page load, doing the calculation once, and saving it in a place where it can be accessed later. Persistent caching would be saving stuff between page loads. So this is saving a value that can be used later in a subsequent page load in memcache usually, but also possibly in the database. And then this third one we've seen implemented recently in some interesting ways, kind of setting guardrails or boundaries in code around what the maximum frequency of certain events during a page load are. So this again would apply to things like variable stuff like widget areas, other stuff like that. Like we often see outages associated with unbounded data changes. And so we've seen some interesting examples of folks limiting the sort of number of widgets that can be presented on a page, or the amount of stuff you can put into a menu. And here are the actual like parts of WordPress that that do these techniques. So you have the cache functions, which interact with memcache. Same with the transient API. And then we have other ways to cache larger chunks of stuff. So like if you're generating an entire menu and need to save it, we have the large options plugin allows you to do that. Other techniques to save pieces of pages in a database rather than doing the expensive multi-query recalculation of those parts of the pages. And then we have query caching itself, which is built into our platform, which will save you from doing repetitive queries. So this is going really fast. I'm not going to go like deep. Yes? Yes, I believe so. Yeah. Because I know it does because we get the alerts. Can you guys verify that? I'm pretty sure it does. Yeah, yeah. David Newman, perfect person to tell me. Yeah, the same rules apply there. Like we get the same alerts, I know, for Go sites. Yep. So that's a good point. So like, as you're using some of these APIs, some of them are going to be backed by Memcache. Can't book very, very large items in Memcache, so you want to use alternative caching strategies for those items. And then reducing cost or weight. So this is like, if the event has to happen, let's make it as quick and optimized as possible. For this kind of stuff, we're doing things like query optimization, using Elasticsearch where appropriate. And then in terms of remote requests, it's why we enforce low timeouts for remote requests and promote stuff like graceful failure for remote requests. So one thing I've noticed over the years is that second item, graceful failure, is often kind of the more difficult. So how people often wonder, all right, VIP is making me have this like super low timeout for my remote request. There are definitely techniques where you can do that, but still preserve the integrity of your app, even if the timeout is exceeded. You can, for example, remember the old response, even for a little extra time, and use it if your remote request is not successful. So again, I'm just totally hand-waving at these techniques. There's a lot of great documentation on VIP. I'll send out links to that as well, about the hows and whys of each of these. OK. So I'm going to move right along, and let's talk a little bit about the tools we have available to do some of this work. So at Mo's wise suggested, I've sort of like organized these into 3 stacks. So and kind of increasing specificity. So we have some great performance and profiling tools available on the platform. One is more suited to sort of a macro view of what's going on with your site, still super powerful. If you need to drill down further, there's a couple of more tools you can use, and then I'll describe one technique that really kind of answers all of your questions if you need to go there. So New Relic is kind of our macro tool for understanding the performance characteristics of your site and how your pages are generated. So this has been available on all Go sites since January. It's unfortunately not available on WordPress.com, so extra incentive to do that change. I actually would. What's that? It's free. Yeah, yeah, yeah. It's available on all Go sites. So if you have a Go site, you can use it. So it's not on WordPress.com. So move over. I would move just for this. I like look at New Relic all the time. It's a super important tool. It provides a really good kind of broad view of what's going on your app in a live sort of way. What are the slow queries? What are the slow actions and filters? It is a highly WordPress-specific section where you can understand how WordPress is executing. And for me, it's like the #1 place to start when I'm trying to address an unknown or mysterious problem with page generation. So here's an example of a useful New Relic screen. I believe this is the WordPress. Yeah, this is the WordPress hooks view here. So you can see this right here is such a useful view. It gives you the top 5 most expensive hooks right now on your site and how much time they're consuming in terms of page generation. I think there are some other options here, like how many times during the page load the hook is firing. So that's useful for determining one of those 2 metrics, right? Like what's happening a lot And then I think the other thing you can immediately see here is the average execution time each time the hook fires. So this is like super go-to place and gives you an overview of what's going on. There are lots of, by the way, other useful bits and pieces on the side here. So if you haven't checked out New Relic on your Go site, go for it. There's great stats on your queries and how they're performing. What are the worst queries? What's taking up the database wait time? And a whole bunch of other stuff. So extra incentive to move to Go and extra incentive to use New Relic in this way. If you need help setting this up or integrating it with any of your own tools, we're happy to do that. So reach out to us if we can help with that. So then if you need to drill down a little more and understand what's going on in your site in a more detailed way, perhaps really drill into what's happening in one of those hooks or in a query, we offer some debugging plugins, Query Monitor and Debug Bar, essentially. So Query Monitor is built into Go. It's sort of it's the debugging plugin of choice on that platform. And that's just also built into the platform, so you should be able to use it. If it's not appearing for you, I think there's a couple tricks you have to do to get it to appear for certain types of users, so we can help, again, make sure that's working for you if it's not. There's actually a user capability I think you have to add in order to fire that up for different users. But for those of you who haven't, how many people use Query Monitor here? Cool, so quite a few. So I won't spend a lot of time talking about it. It has sort of a next level bunch of detail about what's going on your app. So queries, and the cool thing here is these are organized by caller. Like remember, this transition right here is why this plugin is so cool. It takes the WordPress API call and directly relates it to the problematic query, which is exactly what we want. Here's a view that I really love, queries by component. How much is each of your plugins contributing to the badness that's going on right now on your site? It's another useful view. And again, tons more of these. I believe also, I don't have a view of it here. But even if you just like open this menu, this clicking here will open a drop-down that gives you a quick view to many of these facets. And if Query Monitor thinks there's an issue in one of them, it'll like highlight it in red. So immediately you can see what the place you need to look. So once again, this is built in to Go and available now. There's an analogous plugin on WordPress.com called the Debug Bar. So this is what we use internally to do some of this same work for WordPress.com based sites. It's just a platform difference that we have access to one in one place and the other in the other. But this is super valuable as well, totally worth installing in your local environments. Easy also to turn on, and the mechanics here are that you just add a query variable to your requests, and you see this overlay here instead of the page render, and it has tons of this diagnostic information. So a lot of the same stuff that you'll find in Query Monitor. Here's the slow actions view of Debug Bar. So a lot of this same ideas. On WordPress.com, this is actually sometimes not super useful because there's always a ton of stuff that happens on init and footer. So it's more this sort of middle area that's sometimes more interesting. And then if you really need to get into it, at this level, perhaps those tools haven't totally solved your mystery. You don't know where the bad, slow object is coming from. The real go-to and gold standard here is like still profiling. And this is using Xdebug and outputting that big dump of data to cache grind, and then looking at that in a viewer that can handle cache grind files. How many folks have done this or know about this technique? Okay, cool. So a little fewer, but still lots. So this is something that we're very happy to help you get used to and learn how to do. This is sort of another level of detail as compared to a tool like one of these. It will get you to the level where you can investigate the full stack trace of all of these individual slow events and definitively solve any PHP-related slowness. So that's like a super quick tour of, yes? That's a good question. I use it on Go, but I'm not sure for clients. Do you guys know if, I think it's something you'd probably likely do locally rather than on the server, but that's something I can check. I should probably know, but I actually don't. Anybody, any other VIPs in the room? No?
It'll have to be done through a sandbox.
Yeah. That's what I was thinking, but yeah, I didn't know if there was.
Sandboxes come in the future.
Thank you, David. Okay, so as I thought, not something that we have for clients now, but if we introduce client-facing sandboxes, that sometimes it would become possible. Yep. Cool. But it's still worth doing, particularly locally. I generally do this on my local environment anyways, and it is pretty definitive. So anyway, I won't go into the details of this, but if it's something you want to find out more about, please talk to us. All of this is to say, like, all of these techniques are geared towards understanding when you implement a particular WordPress pattern, whether that's an architecture decision, a coding decision you're making in a template or a plugin, what are the actual performance outcomes, the performance metrics that result from it? And these tools, like, their overall purpose is to help you understand that. So I wanted to take a moment and talk about, all these relate sort of by default to headful or traditional sites that are not running JavaScript front ends, for example, and relying on the REST API. But it's sort of a new area to think about how you do some of the same work and the same profiling work in terms of sites whose backends are REST API endpoints. This is something I've been thinking of. I'm thinking of one because I have a ticket with him and Sal right now where I've been trying to do some of this profiling and actually finding it quite difficult. There are some plugins that are making strides in trying to implement some of this same profiling stuff for REST API endpoints. Query Monitor has some capacity to do this, but it's not super mature and doesn't provide you all of that good data that you get from others. And I've been working internally on a tool that does the basics of some of the query outputting and stuff that you see for traditional sites to REST API endpoints. But I'm just kind of curious, for those of you who work on endpoints a lot and think about performance, are there tools that you use now for this? Wow. Okay, I'm going to take that as a sign that I'm not alone here and that we need better tools for this. So if that's something you want to talk to me about after, I'd be happy to. It's something I'm thinking about more now. Okay, so understanding that we have all these tools available, we're trying to reduce the frequency and the cost of some of these operations that compose our page load. There's a long way sort of between understanding that that problem exists and making it real on your team and committing to doing something about it. So I want to take a moment and just talk about implementation of some of these ideas. What can make this real on your team, or at least make your teams a team that is at least eligible to think about some of this stuff? So the first thing that we find is that making these tools, some of them that we've described here, available by default as part of your development suite or part of your tool set internally is really important. So when you onboard or train a new developer, like, are you talking to them about how to use these tools, how to assess the choices they're making when building WordPress plugins? It was certainly one of the first things I was trained on coming onto VIP, but that's sort of natural. But I think even on teams that are building products, it's an important thing to make part of onboarding, part of the standard facts of life of being a developer. Then we move into, like, the idea of is your build or your testing process aware of the performance costs or implications of new features, right? So that's something I think Rick talked about briefly at the end of his talk. Like, are the individual developer choices we're making every day, does this stuff even kind of enter into that? And if so, how? Like, is your build checking how fast pages generated this time the app was built versus last time? Are your testers aware of it? And then there's the issue, too, of prioritization. Like, even if you find a problem, is it going to make it up the backlog to be something to worry about? So I guess in terms of your team, there are some beginning questions that I'd think about. Like, the first is to establish a baseline and know the current state of your page load. If you don't know how fast you are now, it's difficult to figure out if you're getting faster or slower. And then some next steps would be to figure out what it would mean to set team and product goals and how you would even understand the cost of new features. So I'd love to hear how you guys do that now and if those are things you think about and what it would mean. I know, Klaus, you mentioned to me you've been on teams in other contexts where not only is there a revenue budget for a feature, but there'll also be a millisecond budget. So here's a new backend feature we want you to implement, and you can't impact page load more than X amount. I'm not sure that would work in all contexts, but it's a real challenge, right? If some folks are out there thinking about that, like, why aren't we doing that in WordPress? And could we? And what would it look like? So finally, I just wanted to mention that this is one thing that we have a lot of experience helping folks with. I think it's kind of one of our strengths. And so if this is an area of work that interests you or that you think you would benefit from learning more about, we're certainly happy to help. We do routinely do performance reviews for clients. Those are just things that are just a part of the service. So if you are worried about a high traffic event coming up, for example, or need help in a particular part of your app, we're happy to have a look and give you an overall picture of how you're performing now. Help with profiling, debugging of difficult problems, we certainly can do that. So just even opening a ticket and mentioning the problem will help you solve it. Help with more sort of architectural solutions, like if you're making a decision about which way to go with something, we can help you assess the performance impact of the choices you're making. And then certainly help with tools and learning how to use those tools is something we can do too. So I think that's all I really wanted to say. I wanted to leave time at the end specifically for questions about this stuff, but also, we just heard a great talk about lots of front-end things that I didn't cover at all here. So if there's any remnant questions from that or discussion you want to have about back-end stuff in particular, I think we have a little time for that. But thanks, guys.